Of the world's food is lost after harvest and in the distribution chain prior to retail, and an additional 17% of food available to consumers is wasted. Food loss and waste account for 8 to 10% of the world's greenhouse gas emissions. Carbon dioxide is generated at every step of the food supply system, from production to handling, transportation, storage and distribution, regardless of whether the food produced is consumed or not, leaving a significant carbon footprint. In particular, the rotting of food waste in landfills and open dumps is adding considerably to greenhouse gas emissions. Greenhouse gases contribute to an unstable climate prone to drastic environmental change and extreme weather events. These unstable climate conditions negatively impact crop yields, reduce the nutritional quality of crops, disrupt supply chains, and threaten food security. Reducing food loss and waste plays a key role in transforming agri-food systems. It can improve productivity and ensure natural resources are used more efficiently, contributing to economic growth and benefiting society as a whole.
What if the solution to energy and environmental challenges was already in our hands, hidden in the waste we throw away every day? Today, we present a smarter, sustainable approach, which is converting the organic waste into a green energy.
Assalamu alaikum. Thank you for this opportunity. Mr. Khalid and Ms. Munira, my MN students, will take you through the project.
Assalamu alaikum. Myself Khalid al-Roshdi.
I'm Munira al-Muqbani. Today we would like to present an ideal solution, which is a hybrid anaerobic digestion system, which solves a significant issue facing whole countries, especially the GCC country.
So do you know that, Munira, around 70% of waste in GCC countries is just organic waste? And this organic waste, what do you think they are doing right now with this waste?
Maybe they are landfilling, going to
Exactly.
landfill.
So what's happening now here in GCC's countries and also in Oman, that this valuable source, it just go to the landfill. And how much it costs per month? It's around 5 million Omani riyal. So imagine that instead of we are using this valuable source, that we are just dump it in the landfill, and it's burden for the country.
Our agenda will be an introduction, then we will go deeply to the problem, then the waste analysis in Oman, then we will show deeply the proposed solution, and then we'll go also to explain it from the technical side and financial aspect, then we will conclude our presentation.
So moving to our solution, that we have divided our solution into 3 phases to keep it in reality. So phase 1 is already in the ground, it's a learning platform. So what we have done, we have collected all the organic waste from Sohar University restaurant and nearby restaurant. We have put it in the biodigester, and we are able to produce a biogas. So if we see here that from the chart, from the biodigester we have the biogas, and we're able to reach from 64 to 74% methane, and then we have the the digestate, which have liquid and the sludge, which going for gravity settling. So this is phase 1. Phase 2, that the biogas first will need to have some conditioning. We need to remove the moisture content, because when we did the testing, we found around 10 to 15% there is a moisture content, and there is a trace amount of H2S need to be treated before going for our main unit, which is combined heat power. So what combined heat power can be done? It can convert the biogas into green electricity. So this green electricity, we will use it to run an electrolyzer, and this electrolyzer will produce a green hydrogen. So the idea from just a waste dumped to the landfill to a green hydrogen. And not to forget that we'll have the digestate. This digestate will go for a treatment. We'll use some microalgae that can consume all the contaminant in the sludge, and then we'll have this separation unit will have a liquid that can be reused in the facilities, and then we'll have the digestate, which can be used as organic fertilizer that can be utilized in the country. So now let's move to the prototype that which is already in the ground with my colleague Munira.
As Khalid mentioned before, the first stage is already implemented, and as a diluted water, we are using two types of water. The first one is tap water, the second one is sewage water. When we are using the tap water, we reach methane percentage in a range of 65 to 70. And while we are using the sewage water, we reach above than this, more than this, which is we are reaching 74.8%. So when we are using sewage water, which is already issue on wastewater management, we reach more concentration of methane. And this chart shows that we are when we are using tap water, it is only in a range between 65 to near to 70, but by using sewage water, we reach 74.8. And also the competitor analysis related to our idea. First things is the green hydrogen production facilities. They are producing the hydrogen depending on solar panels, and that is environmental way, but they are not reducing or nothing related to organic waste. So by our idea also we try to reduce the organic load. Also the waste collection system, like in Oman we have a BIA, they are collecting the waste and dump it in the landfill, but this way it has a high emission of methane, and also they are not recover any value from this waste. And also some competitor like incineration of this waste, and they get a steam. From that steam they are run turbines which to generate electricity, and by this way we are producing more emission. And also the energy recovered by combined heat and power system, also they are producing electricity, but they are depending on a large reactors, and it is costly. And when we compare this competitor to our idea, by our idea we treat the organic waste and also producing a green electricity, and also we can use the water which is coming out from the system, and also as a future plan we can produce a green hydrogen from the waste. So we are converting the organic waste which we are throwing daily to a valuable resource of energy.
So now moving to financial aspect to make this project in the ground, to make it reality, not just theoretically in the paper. So we have run a deep analysis, canvas model, and what we have obtained is these outcomes. So if we can see here that we have done a risk analysis, that it's not ideal, and it's not ideal, and it's not real that you take all the waste, for example, in Oman, no. Because if you are just starting this system and you cannot take all the waste from Oman that can be treated. So what we have done, we have taken a portion and we have run the analysis. So if we can see here that when we get 0.25% of this waste we get treated with our system, we reach a payback period 1.5 year. And you can imagine this only we are just considering the avoid cost of landfill. We are not considering all other costs. If we are considering all other costs, will be, you can think how much ideal our solution will be. So at the beginning, we can suggest that we have 45,000 Omani Riyal, which is a capex cost, and the return payback period is 1.5 years, with the net saving in annual basis around 32,000 Omani Riyal. So to conclude that, so from waste just going to a landfill to green hydrogen, yes, it's look very big, but if we go step by step in phases, we believe that we can reach to this target.
You are right, and also we are reducing the organic waste and the methane emission, and plus to enhance our income and saving the money.
So thank you very much, and inshallah will be the best for the future for GCC's country.
Inshallah, thank you.
Assalamu alaikum.